In this lesson, I'm going to explain a little about particle systems, but first, let's look at the program for this lesson. It's just a fountain, basically, that's shooting out particles that are changing color. And that's our program. What a particle system is it's a bunch of particles that are flying around according to simple rules. So it's kind of like the program you just saw. And particle systems can be used to simulate a bunch of phenomena, such as sparks, fire, explosions, or snow. And particle systems are actually relatively straightforward, relatively simple, even though they look pretty cool. For this particular particle system, we're going to be using a different type of texture. We're actually going to have a texture that has an alpha channel. And what that means is that each pixel, instead of just having red, green, and blue components, they'll also have an alpha component, which indicates how transparent the pixel is. Because if you look at the program for this project, if you look carefully, you might notice that each particle is represented sort of as a circle that's more bright in the center and sort of fades out towards the edge. But actually, that's more clear if you look at the images for the picture. We're using two images, actually. We have an image that stores the basic red, green, and blue components of the image, and this is just a completely white image. Then we have a separate image that has the alpha channel for the image. It stores the alpha components of each pixel in the image, and it's a grayscale image. So the pixel white will represent an alpha value of 1, whereas black will be an alpha value of 0. And this is the alpha channel for the texture that we're going to be using for these particles. Some image formats, such as PNG, actually support an alpha channel where you can have a single image that has an alpha channel built into it, but the bitmap file format doesn't really like alpha channels, so we're just using two separate images. And let's see how exactly we can put in an alpha channel into a texture. So in order to get an alpha channel into a texture, we're actually going to have a special type of array. Before we had an array that represented just the red, green, and blue components of each pixel. If you'll remember, they went through all of the pixels in the image in a particular order, and they specified the red, green, and blue components. But in this case, we're going to need an array that specifies the red, green, blue, and alpha components of a particular image. So we're going to basically just take in an image and its alpha channel, grayscale image, and we're going to get it set up into this pixels array that's going to have the red, green, blue, and alpha components of each pixel. So that's what this add alpha channel function is going to do for us. We're going to iterate through all of the pixels in the image, and we're going to set the red, green, and blue components of each pixel in this pixels array to be the red, green, and blue components of the image, of this image object. We're also going to set the alpha component of each pixel in the pixels array to be the alpha component, or to be actually an arbitrary component in the alpha channel image. So I just picked the red component. We're using the red component, but you could actually use the green or blue component. Doesn't matter because it's a grayscale image. Then we return the array that we've just put together. So that's the add alpha channel image. It basically just takes an image and an alpha channel and puts them together into an array. Then we have a load alpha texture function, which is basically going to be the equivalent of the load texture function, but for textures with alpha channels. And what we do is we first call the add alpha channel function that we just saw in order to get everything nice into this array over here. Then the rest of the function looks pretty much just like the load texture function that we've been using in previous lessons. It has glgen textures, glbind texture, and gltextImage2D. The only difference really is that instead of GL-RGB for the format type of the texture, which are these two parameters right here, we're putting GL-RGBA to indicate that we have a texture that has alpha components for each of the pixels. So that's the load alpha texture function, and as you can see, we call it over here in init rendering. We call it to load in an image with an alpha channel, or rather a texture with an alpha channel. And that's basically how we can have textures with alpha channels. Now let's take a look more into the actual particle system. First of all, we have a random float function, which just returns a random float from 0 to 1. But then we have a structure which stores all of the information about a particular particle in our fountain. It stores the position, velocity, and color of the particle. And for each particle, it also stores the lifespan of the particle, which is the number of seconds that the particle is going to be alive. And actually, we're going to have each particle fade out using alpha blending. So at first, the particle will look exactly like the texture that we've just loaded in. And then once the particle has been alive for half of its lifespan, it'll look half faded out. So basically, we'll multiply the alpha component of each pixel by 0.5. And once it's almost gone, we'll be multiplying the alpha component of each pixel by almost 0. So this lifespan field and this time alive field will help us do that. Time alive is the amount of time that a particular particle has already been alive. Then we have a rotate function, which rotates a particular vector about a particular axis a certain number of degrees. And we'll need this because we need to know the exact position of each of the particles. We can't use... we're going to actually rotate the camera by 30 degrees about the x-axis, and we can't do this using GL rotate F. That's because we have to be able to sort the particles from back to front. We have to know where all the particles are. Actually, I shouldn't say we can't use GL rotate F, it's just that we're not going to. But it is important that we know where each of the particles is, so that we can sort them from back to front. And we're going to have this ADJ particle pose function, which is going to take care of adjusting a particular particle's position so that it looks like the camera is rotated by 30 degrees. Then we have a function compare particles, which is just going to help us determine... it's going to help us sort the particles from back to front. So it returns whether the adjusted position of the first particle, whether the adjusted position is behind the adjusted position for the second particle. Then we have some constants. We have the gravity in units per second, which is going to be applied to all of the particles. We have the number of particles, because actually we'll just have a fixed number of particles, and every time a particle dies, we'll replace it with a new particle. Then we have a step time constant. And what we're going to do is we're going to step the state of the particle engine, of the particle fountain, by small amounts of time. So we'll sort of advance the state by 0.01 seconds every 0.01 seconds. And we'll have a special function called step, which will advance the state of the particle fountain. Then we have a particle size variable. So each particle is going to be drawn as a square, which is perpendicular, which is parallel to the camera, parallel to your eye. And the particle size constant indicates how long each side of the square is. So that's what this constant is. We have a particle engine class, which actually stores all the information that we need to know about the particle fountain. And first of all, we have the ID of the texture for each of the particles. We have information about all of the particles. We have this variable right here, time until next step, which is the amount of time until we next call the step function. Then we have this color time variable, and that's going to be used in order to have that effect where we had the particles changing color over time. At first, the color time will be 0, and it'll keep increasing. Once it reaches, when it's at 0, that represents a color of red. When it gets to 1/3, that means that we're at the green color. And when it gets to 2/3, we're at blue. And once it gets back to 1, then we're back to red. And color time will jump back down to 0. So this is going to help us have the particles change color over time. Then we have a variable angle, which stores the angle at which we're shooting out the particles, because our fountain is spinning. Then we have this function curColor, which is the color of all particles that are currently being produced by the fountain. So what it does is it takes the color time variable and it returns a color based on that. So if color time is 0, it's going to return red. If it's 1/3, it's going to return green, and so on. And it's going to take care of all the shades in between that also, right here. So you can look at exactly how that works. And then we have right here, we're making sure that all of the components of the color lie between 0 and 1. So if there are some kind of rounding errors or anything, one of the components might be below 0 or above 1. So this will just make sure that they're between 0 and 1, so that they actually represent a color. And then we return the color once we're done. After that is this method, curVelocity, which returns basically the average velocity at which the fountain is shooting out particles. The velocity varies a little bit if you look at the program. They're not shooting out all in exactly the same direction. They sort of have a range of directions in order to make it look more interesting. But curVelocity is the average velocity at which we're shooting out particles. And it just uses the angle variable in order to figure that out. Then we have a createParticle function, which whenever a particle dies, we'll just call createParticle on that particular particle object. And that'll set all of the fields of the particle object so that it's as if it were a new particle, a brand new particle. And what we do is we set the position to be 0, the origin. We set the velocity to be the curVelocity, the result of this curVelocity function, plus a random vector in order to get that random dispersal of particles. Then we set the color to be the current color, which, as I said, varies over time. We set the time alive field to be 0 because this particle hasn't been alive for any time yet. And we set the lifespan to be a random number between 1 and 2. Then we have the step function, which advances the state of the particle fountain by step time seconds. First of all, it changes color time and angle. It adds some number that's proportional to step time to each of those. And it makes sure that the color time lies between 0 and 1, and that angle lies between 0 and 2 pi. This angle, by the way, is represented in radians, not in degrees. Then we have where we go through each of the particles and we advance its state. So we just increase the position by the velocity times the step time. And also, in order to simulate the effects of gravity, we decrease the y component of the velocity by gravity times step time. Then we increase the time alive variable, and if the particle has been alive for longer than its lifespan, then we want to destroy the particle and to create a new one in its place, so we call createParticle. That's the step method. Then we have the constructor, which just initializes these variables right here, and it creates all of the particles, or creates 1,000 particles in this case, and then it sort of advances the particle by 5 seconds, by a particular amount of time. And let me show you what happens if we don't advance it. It'll look really weird, because the thing is, we create all of the particles at the center of the fountain, and if we don't advance it at all, then it'll look really weird like that. They'll just all shoot out from the middle. So, sort of, it takes a little time for this particle fountain to get going where it looks normal. So that's why we have to advance the particle by a little bit at the beginning. And then we have a function called advance, which just advances the state of the particle fountain by a particular amount of time. So it takes care of calling step the appropriate number of times and changing the time until next step variable. Then we have our draw function, which draws each of the particles in the fountain. The first thing that we have to do is sort the particles from back to front. So we'll just store all the particles into this p's vector and then call the sort function on that particle. Again, we have to do this sorting because we're using alpha blending, and in order to do alpha blending correctly, you have to draw everything from back to front. Then we set up our texture stuff, and we actually draw all of the particles. So we go through all of the particles in order from back to front, and we call GL color 4F because, like I said, we want the particles to fade out. So they'll start... at first, we'll have an alpha value of 1 that we're applying in addition to the alpha values of the pixels on the texture. And once the particle has been alive for half of its lifespan, we'll have this alpha value be 1/2, and when it's about to die, this alpha value will be about 0. So this will just make each of the particles fade out over time. Then we have this size variable, which is just basically conveniently storing particle size over 2 for us. We have this position variable, which is going to keep track of the adjusted position of the particle. Again, the position after applying the effects of rotating the camera. And then we draw the particular vertices of the particle, which is right here. Again, it's a square that's parallel to the eye. So that's what these calls right here do. And that's our particle engine class. After that we have timer ms, this constant, which is just the number of milliseconds between calls to update. We have a particle engine variable, which we delete in the cleanup function. We have all of this stuff we've seen before about loading in textures with alpha channels. And we have our draw scene function, which just calls draw on the particle engine. Our update function just calls advance on the particle engine. And our main function actually just constructs a new particle engine. That's the one new thing that we have in our main function. And that gives you an idea of how this one particular particle engine works. So how we can have this nice looking fountain effect.